Welcome everyone. My name is Vishal Gamji and I'm representing Team System Savants. My team members are Harshada, Subodh, and Gibran. Here's our story to follow in 5 chapters. For this year's winter Katas, we have a medical device company, medical software company called StayHealthy that wants to build an on-premise solution hosted at hospitals for monitoring patients' vitals data. They currently have 2 popular cloud-based SaaS products, Monitor Them and My Medical Data. StayHealthy is exploring growth opportunities with MonitorMe, a real-time patient monitoring solution for hospitals, and wants to integrate with its existing EHR system, My Medical Data. The next chapter is where we start getting into technical complexities of handling variable rate data emissions coming from IoT devices while still considering reliability, high availability, real-time operations, and low latency. There were deployment and hosting considerations given the solution had to be hosted on-prem, and this was a business risk for StayHealthy as they hadn't operated in such a business model before. Also, there were integration and interoperability requirements to consider. And finally, future scalability and future expansion considerations. These are not exhaustive by any means. We do list out the architecture characteristics in the implicit ones and the explicit ones in the upcoming slides. So let me walk you through the process of untangling these complexities at a very high level. Yes, there was a method to the madness to untangle these complexities to understand the requirements and coming through and having a process to this analysis. We start by looking at the actors, actions, and components, like breaking down the requirements into like personas, actions, and functional components of the system. Next, we look at the pool of candidate architecture characteristics and decide which ones should be the top 7 driving characteristics of our system with a key focus on the top 3 as shown in this slide. Next up is the capacity planning exercise to understand the data and throughput needs for our system. Finally, based on the analysis that we did with the actor, action, and component analysis, architecture characteristics, we decided on selecting an architecture style that fits our needs, which was a mix of microservices and event-driven architecture. Now, the next chapter gets, I think it should be titled Difficult and Conflicting Conversations for the Introvert Kind. Just kidding there. In this chapter, the team did a great job debating on conflicting choices. For example, REST versus gRPC versus MQTT as a protocol for interacting with IoT devices and the data. And the key was to document these choices as architecture decision records that supported the requirements and the architecture characteristics that we picked. So let me highlight 3 examples of ADRs. Here's one which shows we selected Kubernetes for its high availability and scalability requirements. We also mentioned that the microservices architecture is partition tolerant, modular, and maintainable. Here's another where we highlight Ambassador API Gateway deployed in self-hosted mode in a container pod to support the integration with My Medical Data. Here's another one that highlights the AWS Outpost servers being used for on-premise installation in a hybrid cloud setup. Finally, we get into the solutioning, the eureka moment. Combining all the analysis, the architecture selection, the architecture style selection, and the ADRs, this gave us a framework and a mental model with parts to pull in and build our high-level architecture. Note that we only used our C1 and C2 levels in the C4 model intentionally because of given the complexity. Here's the system context diagram. I'll zoom in into the MonitorMe to get into the container diagram. And I'll zoom in further into the microservices box to give you another level of detail. Finally, we look at the deployment diagram. with 2 outpost servers for high scalability, high availability, and then auto scaling for microservices in EKS uh, to give us the scaling options and the database as shown. Finally, we get to the end. In conclusion, we hope that the solution we covered, where we presented, covers all the business requirements and will help build a working system which will enhance patient care. This has been a great opportunity to learn end-to-end system design and architecture. So thank you.